Hi guys, alright, so this one it says that we have to perhaps multiply both equations by a constant to eliminate. So let's jump into example 3a. So looking at these, I'm going to look at my x's and I'm going to look at the smaller one. 3 times nothing gives me to a 10, okay. So I go to my y, to the smaller one, 2 times nothing gives me 5, okay. So let's just say that I want to eliminate the y's in here, okay? And I'm going to multiply. Well, the y's, remember, they have to be opposite signs, right? And the same number. So what happens if I take this number, this coefficient, and multiply the top by that guy? And then I can take this number and multiply the bottom by that. But because they were both positives, one of these numbers needs to be negative. It does not matter. So I'm going to like the smaller number to be negative. So let's see what our new equations are going to be, okay? So let's start with the top one. We're going to get now a 15x plus 10y. And then 5 times negative 9 is negative 45. Now let's work with the bottom one. Negative 2 times the negative 10, so that is what, positive 20. Negative 2, positive 5, that's a negative 10y. And then negative 10 and a negative 5, that is a positive 10. Again, look at the work, make sure it's perfectly organized on top of each other, and let's just add down here. Okay. 15x plus 20x, that's a nice 35x. Our y's cancel, and we get this, I'm going to double check, negative 45 plus 10, negative 35. Awesome. You guys are pros at this point. Let's get that x by itself by dividing both sides by x, and we get a negative 1. Let's set ourselves up for success. Put that x value into the first slot, and then you are back to doing the same stuff, right? Pick one of the two original equations that look easier to you. I'm just going to pick the top one, okay? So 3x plus 2y equals a negative 9. I'm going to substitute that negative 1 for the x spot. And let's clean this up. 3 times negative 1 is a 3. 2y equals negative 9. Inverse operation. Let's add 3 to both sides. 2y equals negative 6. And let's divide both sides by 2 to get that y by itself, and it being a negative 3. And let's make sure we plug it into that coordinate. Give that mature answer. Awesome. So the only thing different is like that first step, right? That green and that pink. But everything else is the same, so not too shabby, guys. Alrighty, let's try at least one more. Okay, so let's look at these numbers again. So going to the smaller one, 5. 5 times nothing gives me 7, okay. Going to the smaller one, 2. 2 times nothing gives me 3. So I know I have to multiply the top and the bottom by something. So maybe I'm going to try the x's. I'm going to try the x's because they're smaller numbers, right? And they are already opposite signs, so that's kind of nice too. So I could take this number and multiply the top by it. And then I can take this number and multiply the bottom by it. Because the top equation was a negative already, I don't have to multiply one of them by a negative number, right? So let's see what I'm talking about here. Let's distribute. We get a negative 6x, positive 15y equals positive 60. Now let's get the green one. We get a 6x, negative 14y. Let's double check that one. Negative 26 times 2, negative 52. And now I like that my x's lined up, same number, opposite signs. Perfect, that's what I'm looking for. So let's add down. We know our x's are going to cancel. 15 plus a negative 14, that's just a 1y. 60 minus 52, that is an 8. Awesome. Set ourselves up, put that 8 in the y slot, and now let's solve for x. Again, pick whichever original equation looks easiest to you. I'm going to pick the second one. So 3x minus 7y equals negative 26. Let's plug in that 8 into the y spot. And let's start solving here. So we got a 3x, 7 times 8, okay, 56. Awesome. Let's do inverse operation, adding 56 to both sides. Let's double check with those negatives. Negative 26 plus a 56. All right, nice. 30. Divide both sides by 3. And x is equal to, I'm going to double check, 30 divided by 3. Okay, cool, 10. So go in, plug that 10 into your coordinate. Awesome, guys. So we just practiced with two problems, making sure we're able to multiply both equations by different constants. Awesome job. So let's figure out when do we want to use this elimination method, okay? And when do I want to prefer to use this? We want to prefer using this when your equations are in standard form, right? That's kind of the nicest way to use this. If you maybe have a slope-intercept one, you have to, change some things, move that x over, so you have some additional steps. But as long as it's in standard form, I would want to say that elimination might be the easiest method to use, okay? Awesome, guys. Make sure you go to part 2. Keep up the great work.